Okay, welcome to this new unit on in our systems administration course, and we'll be looking at regular expressions. Now, um, since you have taken programming languages, I assume that you have some familiarity with regular expressions. However, we will basically start from scratch. Okay, so those of you who are taking programming with me, web development, you've noticed that I have used regular expressions to be able to identify whether an email is valid or whether a phone number is valid. So we want to be able to see patterns in text, and the keyword is text. Okay? And so by the end of this unit, you will be able to understand how to search for patterns in text, how to search and replace patterns in text, and of course, how to do that um, from the command line and also in different programming languages. Okay, so since the best way to understand something is by doing it, let's start off by looking at examples. So we're familiar with the grep command, right? We've used it to search for things. However, we have not really discussed it in detail. And so we want to use this unit to discuss grep in detail. So let's say I want to search for a word, express. Okay. And I want to search for it in USR/share /DICT /words. Okay. Okay. And so by the way, you notice that we have express, and it shows me in red the places, the words that it did find express. Now, it still shows me the entire word. So expressly, for example, here, contains the word express. Okay? Expressionist, expressionless, they all contain the word express. What if I want to search for something else, such as tree? Okay. Okay. So notice, tree is in Broad Street. Notice it doesn't matter if it's inside the word or if it's at the end of the word, it doesn't matter. Okay, and that's because of the way regexes or regular expressions work. And so we will also learn how regular expressions are evaluated. Now, on your system, you probably do not have this, and so make sure you install it. So you would have to say something like sudo apt install W American. Okay, W American. All right. So when you install this, all right, oops, American. Okay. When you install it, you could check for it. So ls-l /USR /share /DICT /words. Okay, and you notice that it's a link to American-English. Okay, so make sure you install this dictionary so that you can follow along. Okay. So moving on, we are using grep. Let's try grep again, but this time we will look at front. Okay. Okay. Oh, sorry, wrong. Yeah, grep. Front. Okay. So front is found in many words. And if we look at back, Back is also found in many words. For example, sticklebacks, swayback, switchback, and so on. Okay, so let's move on and let's look at grep. So if I say man grep, okay, so we see that there are different options. For example, dash V. We have dash F, for example, file, dash I to ignore the case, all right, and so on. So you will have to be intimately familiar with the command line options for the grep tool. Let's look at a few of them just to get you started. I could say something like grep dash C, okay, and that 250. What does that 250 mean? It simply means, so if I say grep dash dash help, right? The dash C, all right, let's pipe it to more, right? Dash C, do I get a C? Yeah, it says count. Print only a count of selected lines per file. So that 250 is telling me that grep saw what I was looking for on 250 lines. So it found back 250 times. If I search for front, it told me it found it 48 times. What if I decide to use a dash N instead? What does that do? Well, it gives me the line number. Okay, it gives me the line number where it found it. Okay, and so in entry 10 entry million 200,002, is that right? Actually it's 102,002. That's the line entry. Okay, so the dash N tells me on which line. So those are just some of the options that we can use for grep. Now, keep in mind, this is just the beginning of grep. There's a lot more to do, but what I want to do right now is just to introduce to you the different utilities, different tools that Linux has that uses regular expressions. Another tool that uses regular expressions, another utility is the find utility, to be able to find files. So for example, let's say I want to search in this location, usr / share / doc / mark. Okay, so what do I want to do? What do I want to look for in this directory? Well, let's grep for the word regular. Okay, regular. This is what we want to look for. Now, whenever I'm using find and I want to do grep, I could have find work together with grep, and so I'm going to simply say grep regular, and let's show the content. So I'll say dash h. Right, show me the things you found. Now this won't work. Okay, it won't work. And the reason it won't work is because when I'm using grep with another command, such as find, I have to tell the command line, I have to tell Linux that I want to execute grep on the things I find from the find command. And so to do that, I want to say dash exec. Everything that is returned by find, I want you to apply grep to it. In other words, I want you to execute the grep command on it. All right, and so I'm going to say regular. Now, there's one little thing I need to add. Open close curly brace. Okay, that open close curly brace is just a placeholder. All right, just think of it as a placeholder. All right, and then of course let's end this statement, this execute statement, by doing that. So backslash colon semicolon is how we end the execute statement. Okay. So what will happen? Find will go through that directory /usr /share /doc /mock, and for every entry that has the word regular, it will display it. Okay. So notice, for example, line 1, there is a regular. The last line, there is a regular. However, on line 1 at the top, it says error, right? grep is a directory. Let's get rid of that. Right? We don't want to see those error messages. So if I want to ignore error messages in Linux, we use the very popular approach, which is to take all errors, which is 2. Remember, 0 is input, 1 is output, and 2 is standard error. Right? So we want to take any errors, such as is a directory, and we want to ignore it. So I want to take anything that is an error, and I want to send it pipe. Sorry, not pipe. The redirection. I want to send it to this location, dev null. Dev null is just a way of saying send it and ignore it. Okay, anything sent to dev null is essentially thrown away. And so if I run this, by the way, you see this quite a lot, right? You see 2, the greater than sign, followed by dev null. You see it quite a lot in Linux. Okay, so let me show you that again. You see now that the error message about a directory has disappeared. So that's the find command. Again, very useful, but again, we're just introducing the find command just to show you that we use regular expressions in many of these tools. All right. Okay, let's move on. Let's look at another tool that uses regular expressions. So to demonstrate this, I'll create a new file. So let's just say touch number dash words .txt. Okay, and let's use nano to open this. Okay, and in this file, I'm going to simply say 0, 1, 2, 3. I'm going all the way to 9, 4, 5, 6, 7, oops, 8, 9, yeah, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's save it. Control O, enter, Control X. Good. So let's cut it. Good. So let's say I want to replace 0. All right. I want to replace 0 in small letters to 0 in all caps. So how do I do that? Well, I can use sed, right, the stream editor. And all I can say is, okay, let's use -i for ignore the case. I want to substitute s, okay. I want to substitute /0 / with capital 0 and then a / and close. Now, where do I find the files to look at the file to look in? Well, I'm going to look in number words.txt. Okay, nothing happens, but if I do cut and number words again, you notice that 0 is replaced. Okay, so it will go line by line and it will check the first line. Does it have a 0 small letters? Yes, I'm going to replace it with all caps 0. And then it will move on to the next line, which has 1. And since it doesn't have a 0, it just keeps going until it ends. It reaches the end of the file. If I have another 0, let's add another 0. Let's say echo 0, sorry, 0, to this file. Okay. And then if I cut, you'll see that there's a 0 at the end. And let's try to run our command again to replace. And let's see if it replaces that new 0. It does. All right? It does. So that's how we would do that. Now let's try something else. I want to add another 0, but this time I'm going to add it in line with the first 0. Okay, so I'm going to add 0 here. 0. Okay. Let's change this back to 0. Okay, so I have two zeros. Let's change this back to 0, 0. And maybe let's have 9, 0. Okay. Control O, enter, Control X. Okay, so let's see what happens if I have multiple zeros. Okay. Okay. All right. So what do you notice? It changes the first 0 on line 1, but it ignores the second. It changes the 0 that has 9 in front. And it changes the last line, which has 0, only one of them. So right away, when you look at it, you could see that, okay, it only changes the first 0. So it the way the regular expression or sed works, or even grep, it will only look for the first occurrence. So the first 0 it finds, it will change it, and then it will move on to the next line. Okay, and that's the way it works. It's always first found is considered a success. It finds it, it's a success. Everything else is ignored on that line. So it fixes the first line, moves on to the other lines. It sees a 9 and it keeps searching on that line and it finds a 0. So it changes that 0. And then it moves on to the next line where it finds the first 0 and it fixes it. And since it finds 1, 0, it considers that a success and it ignores the second one. Now, if you want to tell if you want to tell sed to keep going, to check the entire line and to change all occurrences, then you have to use the G option. Okay, so the G means global, meaning do for all of them. Don't stop at the first occurrence, do all of them. Okay, and so now when I check here, I'll see that it has updated all the zeros. Okay, so just keep that in mind. The G is global. Okay, let's move on. So again, regexes are very important, and I want you to start thinking about regexes not as words that we are trying to search for, but as patterns. Okay, we have search patterns. Remember that, search patterns. If you remember that, then you will be okay. So let's say we're grepping in root, well, for root and etc /password, PASSWE, right? We know about this file, right? So it finds one line that has root in it. What if you want to specify which line number? Line 1. Okay. What if we're looking for the word false? All right. There are 3 lines. So obviously if I use -C, it will tell me 3. All right. So that's straightforward enough. Let's switch back and go back to our dictionary. So let's say I want to grep for hello. Okay. Let me not use quotes yet. I'll just use hello. USR, share, and the ICT, and words. Okay. So Othello's, hello, hellos, and hellos. Right? Of course, we see it's five entries, right? 5 entries, and so that's okay. Now let's search for goodbye. Okay, 3 entries. Now this is very important, and I'm going to go back to hello. I don't want you to think about we're searching for hello, because we're not. We're searching for an H followed by an E followed by an L followed by another L and followed by an O. That's what we're searching for. That's the search pattern. We're not searching for words. Regular expressions do not search for words. They search for patterns. Okay? If you can remember that and always be mindful of that, regular expressions will be easy for you. We search for patterns. An H followed by an O, followed by an L, followed by another L, followed by an O. Okay. So let me emphasize that if we have Othello, Othello, okay, and we're searching for hello, right? Regardless of the case, what does the regular expression do? Well, it starts off, it says H. First character, is that an H? Nope, not an H. Okay, well then it says, all right, let's, next one. T. Okay, so is it an H? No, it's not. So it moves on to the next one. Notice, every time we go to our next letter, we have to begin the regex again. The pattern again. So we start at H. Okay, so is there an H? Yes, we have an H. Okay, so we move to the E now. So we're looking for an E. So the regex will say, okay, next character, is it an E? Yes, it's an E. And so the regex will say, okay, we're looking for L now. Okay, so next one is an L. Yes, it's an L. And then it says, okay, we're looking for another L now. Can I find another L? Yes, I find another L. O. Can I find another O? Yes. So I've matched the pattern, and so this is a result. Now, let's say I have something like H, I, and then I have HELL, and then I have I. Okay, so what does the regular expression do? Okay, so does it match an H? Yes, right? We're ignoring the case. H. Okay, so does it match an E? Well, no, it's an I. So what will happen? The regex will now say, okay, right, we have a problem, right? We started with H, don't forget. Okay, so the regex will say, well, I started this thing with the H, which means I have to move on. So I will start a fresh search again. I'll go back to the regex H, and so I will start looking at this one now, I. Okay, so I'm beginning fresh. Okay, so is this I and H? Nope. So the regex will say, okay, well, I have to begin fresh again. So I'll make sure I begin the regex again, H. And now we know I is not something we can begin with, so move on to H. Okay, so yes. We have an H? Yes. Do we have an E? Yes. Do we have an L? Yes. Do we have another L? Yes. All right. Now, do we have an O? No. I ran out of letters. So, this is a false. Nothing is returned. Okay? Nothing is returned. So, that's something to keep in mind the way the regex engine works. It always checks character by character. And so, for example, if I had if I had HE and then another HE with a P, something happens, right? It will check H match, yes. Remember, it started with capital H. Moving on, E matches, H no. So that's where that ends. And so the regex will say, okay, I've finished with H. Let's move on to the next character, E. And so now it starts with E. Do we have an H? No. So it says, okay, I'm done here. What's the next character? Well, it's now a H. I'm starting another check. Do we have an H? Yes. Do we have an E? Yes. Do we have an L? No. But I am out of characters to check, so this one does not match. Okay? So the regular expression machine is, in essence, very kind of, if you think about it, it's very slow, right? Very tedious. It has to do character by character. And every time we break, whereby we don't get a match, and we still have words or letters to check, we have to move back to the beginning of the regex and start over, and move to the next character to start checking again. Okay. Sorry for the long-winded explanation, but you must understand how it works. So let's try with grep, and this time we're going to search for hello, but we also want to search for goodbye. Okay, so we don't want to do them separately. We want to get hello printed. So if you recall, when I checked for hello, when I check for goodbye, I got that. And when I check for hello, I got that. I don't want to do two commands. I want to do one command. So maybe I can do hello goodbye. It returns nothing because there is no hello goodbye. So that's not going to work. Well, can I use and? Nope, something is wrong there, right? Okay, that doesn't work. Can I use maybe No. So with regular expressions, these things don't work. So I will introduce to you the first operator that we use in regular expressions to do compounding. So now we're going to do compounding, right? We're going to compound our search or search patterns. Okay, and so the first pattern is the pattern. So I will say pipe. Hello or goodbye. If you find any of those patterns, list it. All right, still doesn't work. What could be the problem? Well, it turns out that we need to use quotes. And that's why I'm going to say it now. Going forward, we always use quotes around the search pattern. Always. Okay. Does it work? No, it doesn't. We're missing something. It turns out that grep does not understand pipe. Okay? Even though it's a part of the regular expression, the language, the specification for the language, the regular expression language, the language specification document, grep doesn't understand it. There's another version of grep called egrep, enhanced grep, enhanced grep, which does understand it. Okay? So what this is saying is, if you find an H followed by an E followed by an L followed by another L followed by another O, return it. Or if you find a G followed by an O followed by another O followed by a D followed by a B followed by a Y followed by an E, return that too. Now, because we will be using grep, we can tell grep we want to be using the enhanced version of grep with all the features. And so to do that, we simply say grep with a dash p argument. And that says grep, use the latest. Okay, so going forward, we'll be using grep dash h. All right, so keep that in mind. Okay, so let's say I decided to put these in a file. Let's say I just say touch regexes.txt, and I say nano regexes, and I decide to put hello there, and I put goodbye. Okay. So how can I tell grep to use the file which contains the search patterns to run against what I'm looking for? Well, that's easy enough. I can just say grep dash f, okay, the file options. Which file? Regex.txt, and those search patterns in that file, I want to run it against usr /share /dict /words. Okay. All right, so we got that. Shouldn't be a problem. Now let's try this. Let me open nano regexes, and let me put a new line. Okay, so I'm gonna say hello, goodbye, and a new line. Okay, I'm putting a new line. Control O, Control X, Control X. All right, let's see now. Let's try again. Okay, it's a problem. Control C. So if I go back here, it seems because I have a new line. Remember, this is a \n. The regex machine is also checking for the new line character. So it's looking for hello, followed by a new line, goodbye, followed by a new line, but it's also checking for a new line. And so it's basically matching everything. So let's bring this back up here. And so we're only searching for a hello new line, goodbye new line, but not an extra new line. We don't want that. Okay, that's what we want. If I include this, then every word, because remember every word such as an or apple has a new line, right? We know that. When you press enter on your keyboard, all right, when you press enter, it's a new line added. And so if I'm on a new line here, then in essence, I am adding a new line, which is not what I want. So I'm going to bring this back here, and I'm searching for hello, and I'm searching for goodbye. And so I want to leave it right there. Okay. Okay, so that takes care of that. So just keep that in mind if you had the same problem. Okay, So let's look at um, some more patterns. So let's say I say grep and I'm searching for, say, grep dash p. I'm searching for NE. Okay, and let's look in numbers. Okay, makes sense, right? One has N followed by E, and 9 has an N followed by an E. So that's why I get those two lines. Now, what will happen if I say grep dash V? Okay, let's change this. Okay, if I say, oops, dash V. Okay, all right. What do you notice? It gives me everything except 1 and 9. So the dash V, if I say man grep dash dash help, pipe it to more, we'll see that dash V, small v here, invert match. Invert the sense of matching to select non-matching lines. Okay, so keep that in mind. Okay, so let's jump to another regex operator, and it's the dot operator. So what does a dot mean? The dot simply means any character. So the dot means any character except backslash n. Except backslash n. Okay. All right. So let's look at an example. Let's say I say something like grep, and we have O followed by any character followed by an E. Okay, so that's what I'm telling grep. I want you to make sure it starts with an O. I don't care what the second character is, but the third character must be an E. And I will be looking in numbers words. We expect to only get back 1. Okay? So keep that in mind. Now, of course, I could also be checking for an explicit dot. What if I actually wanted to check for O dot E? Let's say I put this in my list. So let's say I have nano, okay, and I decide to put down here O dot E. All right. So how would I do that? Well, lucky for us, we can tell the regular expression machine, I don't want you to treat the dot as a special regex operator, treat it as a dot. And as you know from programming, we can escape a character. So for example, we could say backslash n. So how I'm going to do here is just say backslash. Okay, so treat the dot like a regular dot. And so if I say enter, we get 0 dot E. All right, which is straightforward. Makes sense. Okay, if I take it away, it now means something else. All right, so it will return O and E and O dot E. The N is a character, the dot is a character. So notice the difference. Okay. Okay, so I think we're okay with that. And so, of course, there's also a command which we have git grep. All right. Okay, so I don't have any git repositories on my machine right now, but let's say you are searching for a function. You can simply say git grep and maybe main. Okay. Right. Maybe main, and that will simply list out where main is located. So git grep is very useful when you're searching for some function or for some variable that you're not quite sure in which file it's located. Okay, but we'll talk about that another time. Okay, let's move on. I want to now talk about another operator, which is the caret and the dollar sign. Okay, so the caret means the pattern starts at the beginning of the line. Okay, the beginning of the line. And the dollar sign means that, okay, so comment the pattern, okay, so the dollar sign means the pattern starts, or actually is at the end of the line. Okay, that's what it means. So for example, I might say something like, if I have 9, okay, so if I say grep um, 9, so let's say n followed by an I followed by an n followed by an e num. Okay, that's easy, right? Okay, what if I say that show me everything that starts? It must start, it absolutely must start with a z. Okay, irrespective of the case, so dash I don't care about the case, but it must start with a z. Well, let's see what we get. Right, we get 2 lines. Right, obviously if I take away the case, then I get nothing. Right, so the I tells me it's case insensitive, or PI. Okay, now what if I want to get things that end with E? Dollar sign E. Yeah. So what this is saying is, show me everything that has an E followed by \n. Right? Right? That's what it's telling me. Okay? That's what it's telling me. So let's look at what we have so far to see if that makes sense. So I have 0, 2, 3, 4. Okay. So, okay. Let me fix that. So we have, let's see, 0 wouldn't pass. Of course, I wrote my my regular expression wrong. I'll fix it. All right, the dollar sign comes at the end. So we expect 1, we expect 3, we expect 5, we expect, and this E, O.E. Okay, let's fix it. Okay, so let me fix this. Okay, E, dollar sign. All right, dollar sign at the end. Okay. So We have 1, we have 3, we have 5, and we have that. All right. So the dollar sign means it must end with E. Right. So it must be E and then a new line, which means it's the last letter. Now you will also see this where you have the dollar sign and the caret. So what does that mean? It means that it must start with E and it must be the last character. So in other words, it must start with E and then it must also end with E. Okay? Let me fix it and say, let's say 1. What is that saying? Well, any character, any line you return, any value you return must, at the beginning of the line, start with O, followed by an N, and it must end with an E. It must end with an E. So if I press enter, so begin with O, then N, and end with E. Why does it return 1? Well, because O is at the beginning of the line, E is at the end of the line, and there's an N. Okay? So even if I had something like honey, Honey, that wouldn't work because it doesn't begin with an O, it doesn't end with an E. If I had something like Oney, it still wouldn't work. It starts with an O, it has an N, it has an E, but the E is not the last letter. Okay? Likewise, if I had Bone, right? It has an O, it has an N, ends with an E, but it does not begin with an O. And so in essence, what this really means is that you're looking for words that have 1. Looking for the lines, so lines that have the word 1. That's it. So whenever you have a caret, a pattern, and a dollar sign, it just means I'm looking for that single word on the line. That must be the only word on the line. That's what it means. Okay. Great. So that's essentially where we're at. And so I will leave it here. I know it's quite a bit for you to digest, but go ahead and digest it. Work over what I did, and I'll see you in the next video where we'll continue with regular expressions. It's quite a bit, but again, it's one of those important topics that you need to master because you will see it in your web development career. Okay, I'll see you in the next one.